Okay, hey everybody. So again, I wished I could have been there to teach section 5.3, but we're gonna have to deal. I'm home for the duration, so I'm gonna be doing a video over section 5.3. It does say 5.3 day one in here, but we're gonna do all the section 5.3 notes. I think I've got sections 5.3 all covered here. So this is not really day one. This is like the whole thing. There are guided notes. I must have forgotten to make some copies, so hopefully Mrs. Napholtz has gotten the copies that she needs to give to you guys. So yeah. Okay, so let's start here with section 5.3. And again, this says day one, but we know better now. This is not day one. This is the whole thing. Okay. Now, section 5.3 is all about solving quadratic equations by graphing and factoring. And now, just to kind of preface this, since they are Mrs. Napholtz's guided notes, I actually don't have them with me right now. So if there is something that's a little different, I'm really sorry. Just kind of bear with me and go with the flow. Yeah, that's like everybody's mantra right now. Just go with the flow. All right, so section 5.3 is solving quadratic equations by graphing and factoring. You may be thinking to yourself, why the heck are we factoring? Why are we spending so much time going over factoring? Well, we're going to find in this section that we factor so that we can solve quadratics. Now, what does that mean, solve quadratics? Well, that means a couple different things. That means we can set two quadratics equal to one another. We can set a quadratic equal to a linear. We can set a quadratic equal to 0 and solve each of those things by way of factoring. Okay, so it's a method of solving quadratic equations. Okay, and what the solution to a quadratic equation is really the zero of a function. Now, the term zero of a function is one that could be applied not just to quadratics, but to all different types of functions, to linears, to quadratics, to cubics, to quartics, to logarithmic, to whatever. Okay, to rational. The zero of any function is a value of the input x that makes the output equal to 0. So if I'm thinking about it, it's a number, comma, 0. Well, what is that? That's an x-intercept, okay? So the zeros of the function are actually the x-intercepts of the graph, okay? So start thinking those as synonyms. When I say something is a 0, it's an x-intercept. Another term is the roots of an equation, which we'll talk about in a little bit. Unlike linear functions, which have no more than one zero, if you think about a line here, here's my axis. The zeros of a linear function, well, I'm just going to have one place where it crosses the x-axis. It's never going to be more than once, right? Because it's a linear. Unlike linear functions, which have no more than one zero, quadratic functions can have two zeros. Can have two zeros. It doesn't have to have two zeros. There's actually three different options that it could possibly have. It could have two zeros, like the one that you see here. It could have 1 0 if the quadratic bounces off the x-axis, or it could have no zeros at all if the quadratic never even reaches the x-axis. So it can have two zeros, as shown on the right here. These zeros are always symmetric about the x-axis. That's one of the rules about these zeros and the axis. Because they have the same y value, they are equidistant to that axis of symmetry. All right. Now, finding the zeros using a graph and table, basically using a graphing calculator. So when you have a graph, when you have your graphing calculator readily available to you, you can use your graphing calculator. Let me show you how. Everybody pull out your graphing calculators real quick. So to find the zeros, I'm just going to start by plugging it in. Let's get this out of here. So we got x squared minus 6x plus 8. Okay, I'm going to zoom 6 because I'm not sure where my calculator's been. And that's my quadratic. Okay. Now, you may be able to pick it out the graph right here. Like, look, okay, that looks like it's about 2, and that looks like it's about 4. But can we always say, like, oh, it's about 2 and it's about 4? No, we can't do that. There must be a better way to do that in these calculators, and there is. If you were only to calculate those values, second calculate, look at that second choice, 0. Okay, that second choice of 0. Now, it's going to ask you two different things. It's going to ask you for a left bound, a right bound, and a guess. Okay, so what you're going to do is you're going to put the cursor, I'm going to jump over back here. You're going to put the cursor somewhere to the left of this first 0, and then hit enter. You're going to put the cursor somewhere to the right of that first 0, hit enter, and then it wants you to guess somewhere close to it to find a value. So you're going to hit your left bound. See, do you see my cursor coming along here? So I'm going to go stop just before it, the 0. I'm going to go just after it, hit enter, and I'm going to guess somewhere in the middle. And I was correct. It's at 2, 0. Okay, and let's do that one more time. I second calculate the the 0. And now I'm going to go left bound. I'm going to go somewhere to the left. See, now I'm going to use this. I'm going to say, okay, it's somewhere to the left of this 0. Hit enter. Somewhere to the right of this 0. Hit enter. And then I'm going to try to put it right on where I think it's going to be. So the left bound is somewhere to the left of it. The right bound, look, it's actually giving me arrows. Do you see that? It's saying, okay, I'm going to start calculating values on this side of the arrow. I put it over here. So it's only going to be running values in between those 2 arrows. And I guess somewhere in the middle there. And I was correct. 2 and 4. Okay. If I wanted to see that on the table, you could just click into table and see it right there. Put it over here. We could see it right here and right here. Okay. So those 2 values are the 2 zeros, wherever the y value turns out to be 0. Remember, because that's an x-intercept. All right. So why don't you guys go ahead and try this one on your own. Try to find the 2 zeros on your calculator. Okay, I'm going to go ahead and plug it in. I've got negative x squared minus 2x plus 3. And I'm going to go ahead and graph. And I'm going to start calculating. So I can calculate the 0, choice 2. I'm going to go all the way to the left of this first 0, somewhere to the right of the second 0, or sorry, to the first 0, and then somewhere in between those 2 arrows. Okay, there's our first. Do the same thing to find our second. Second, calculate the 0, and somewhere to the left, trace along somewhere to the left of this, left boundary of that, right boundary here. So notice the arrows up top here. It's going to run values only in between there. So I think it's going to be right around there. And there it is. So we've got negative 3, 0, and then a 1, 0. Okay. So I think you can find that, again, it's really easy to find the zeros when given a calculator. All right. So the 0 of a function, the roots of the equation are all synonyms. Is the value of the input x that makes the output equal to 0. So take a look at this function, x squared plus 2x minus 3. To find the zeros of that function algebraically, and say if we did not have our calculator, what we would have to do is basically factor this and say, okay, if I want to find this coordinate, this a number, 0 coordinate, this is the y value, right? So this has to go in as 0, right? This f of x, this y value, has to be 0. So I'm really solving this equation, x squared plus 2x minus 3 equals 0. And the only way to solve for that right now is to factor it down. If I did not have a calculator, I need to factor this down. Okay, so let me show you what I mean. Okay, find the zeros by factoring. Okay, so what we first do here is say, okay, I want to know when this is equal to 0, when this is a number, 0, when the y value is 0, when the g of x value is 0. So let's factor this down. So we have 3x as our GCF with an x plus 6 when I factor it out. Okay, now when you have that, you can set each piece equal to 0, because basically think about this. What makes this 0? Well, if I'm thinking about this product in between there, either of those 2 values would make it turn out to be 0. If 3x were to be 0, no matter what this turns out to be, it's going to be 0, because it'd be 0 times something is 0, right? I'm going to find what value of x this makes this 0, because no matter what this is, this 3x is, 3x times 0 is going to be 0. So there's actually 2 different options that I could have. I could say, well, whatever makes this 0, or whatever makes this 0. Okay, we'll divide by 3. X is 0, subtract 6. X is negative 6. So those are the 2 values. Yes, 2 values. Remember, I could have 1, 2, or no zeros. We're not going to talk about the fact that we sometimes have no zeros. We'll talk about what that means later on in this chapter. But we have -6, 0, and then 0, 0. So what that means, now that we know about all of this, that means that those are the values. It's running through 0, 0, and at -6, 0, right? We know that it's facing up, right? And we could figure out what the axis symmetry is by taking -b over 2a. So we're just basically like accumulating things that we know about how to graph it by hand. Okay, find the roots of the function, or find the roots of each function by factoring. Okay, so if I want to find the roots here, well, let's get it set equal to 0. Okay, well, that's a difference of squares. 2x minus 7, 2x plus 7. So we can say 2x minus 7 equals 0. 2x plus 7 equals 0. Add the 7, divide by 2. Subtract the 7, divide by 2. So we could say x is equal to plus or minus 7 over 2. Okay, or 3.5 if you wanted to. Okay. Taking a look here. So first step, getting it solved for 0. Subtracting the 12 over to the other side. 2x squared plus 2x minus 12. Okay, so look what I can do here. I can, instead of trying to do this hard type factoring, just factor out a 2, folks. That's going to leave me with an x squared plus x minus 6, which makes that a lot easier. 0 is equal to 2, x plus 3x minus 2. Positive 3 times -2 is a -6. Positive 3 plus -2 is positive 1. Okay, so that means I can set this equal to 0 and this equal to 0. X plus 3 equals 0. X minus 2 equals 0. As long as you don't have an x value pulled out as your GCF, you don't have to worry about it being part of the zeros, because you basically end up with like a 2 equals 0 here, which is a no solution anyway. That's a contradiction. So you don't have to worry about when there's just a whole number. If there was an x pulled out, you would have to set that equals 0, but it's just a 2, just a whole number. So x equals -3 or x equals positive 2, which means I've got 3, 0, oops, sorry, -3, 0, and 2, 0 is my 2 x-intercepts of that graph. Okay, so that's really why we factor. We factor so that we can find the roots of the equation. Okay, that's really the why behind everything that we've been doing. Okay, now here's some cool stuff, some of the projectile motion stuff. At this point, if I were with you this day, I'd be throwing things across the room. Not in anger, for true demonstration purposes, I promise. But to show you that, if you throw anything, if you toss anything, the weight, the acceleration due to gravity pulling down on these things actually make the path of that thing that you throw parabolic. Okay, it actually makes a parabola. Okay, test it out. Like, I'm gonna get in trouble for this, but like, just like toss your pencil up in the air, right? You can see that it goes up. There's an instantaneous point where it becomes weightless, and then it comes back down, right? It stops moving for just a very, very, very minute split second, and then it comes back down. And the acceleration that it's going, it gets faster as it gets toward the ground, right? If you toss your pen to your friend, or toss something over to your friend, and you watched it as a cross section, it would create this parabolic shape. Okay, so like from where I throw it to where it lands again, right? Okay, so that means that this equation is one used in physics that we can model the height, and this, I'm talking about the cross section here. We can model the height of the object thrown. Oops, sorry. We can model the height of the object thrown as h, right? We can model the height of the object thrown as h, and t is our time, okay? Now, so that means we've got this function, h of t is equal to -16 t squared plus v sub 0 t plus h sub 0. Okay, what do these things mean? -16, that is the acceleration due to gravity in feet per second squared. Some of you people in physics maybe recognize this a little bit better, -9.8 meters per second squared. The only difference is there, this is in meters per second squared, where that's in feet per second squared, okay? And then t is time, okay? V naught, or v sub 0, is the initial vertical velocity, okay? How strong are you throwing the thing? And then h naught, or h0, or h sub 0 is the initial height. So if I were to throw this, and that's my y-intercept, right? We learned that. So if I were to throw this at like a height of 10 feet, this would be like a plus 10 sitting out there on the end. If I were to throw it at a height of 100 feet, this would be 100 sitting out there on the end. If I were to throw this, or maybe like I kick a ball from ground level, this would be non-existent. It would be like a plus 0 sitting out there if it was going from ground level. Like this one. A football is kicked from ground level with an initial vertical velocity of 48 feet per second. How long is the ball in the air? Okay, so this is what I'm looking at here. Plunk, right? I want to know how much time gets taken there, okay? Well, those are the zeros of the function, right? What function? Negative 16t squared plus v naught, or v sub 0 t, plus h naught, or h sub 0. Okay, so that means negative 16t squared plus 48t plus, okay, ground level 0. And I want to know when that equals 0, because that's equal to h of t, right? That's equal to my height, my final height. Well, I want my height to be 0 because I want to know when it hits the ground again. How long is the ball in the air? So let's factor this down. I got negative 16t squared plus 48t equal to 0. Let's factor out a, oh, look, this is divisible by 16. Let's factor out the negative too. Why not? Let's factor out a negative 16t. Okay, that's t minus 3. Ooh, and now we sound like we're shooting off a rocket or something, right? T minus 3 seconds. So 3 seconds total. I kind of skipped past it, but we have negative 16t is equal to 0, and t minus 3 equals 0. So divide by negative 16, t equals 0. Add the 3 seconds. So it's at 0 height at 0 seconds, and then at 3 seconds. So how long is the ball in the air? 3 seconds. Okay. So what you do is, if you want to find the total time the ball is in the air, notice that this is not total, like a max height. That's different. That you have to find negative v over 2a, right, and plug it back in. That's asking for the vertex. These are different problems. This is asking, I'm asking how long it's in the air, that's asking for the zeros. Okay, those are two different types of problems. This is max height. This is time in air. Okay, this is asking me for a y value. When you plug in that negative b over 2a, this is asking you for the x value, the zeros, the x-intercepts. Okay. All right, and let's take a look at here. This one. This is the last example that we got here. Write a quadratic function in standard form with the given zeros. So now what we're going to be doing, and we'll do this a lot, throughout the year here. We're actually going to be working backward. I'm saying x equals 4 and x equals negative 7. Find the function that has these zeros. Okay, so I'm kind of starting at the end of my problem, and I'm going to work my way backward because the answer is now, it's like we're playing Jeopardy. The answer is now the question. Okay, so now what I'm going to do is I'm going to work backward. Okay, so let's get those set equal to 0. Add the 7 over. X plus 7 is equal to 0. So these are actually my two factors. Those are my two factors. Oops, forgot my x. X minus 4 and x plus 7 are my two factors, setting those equal to 0, right? And now when we FOIL this together, first is x squared, outer is plus 7x, inner is minus 4x, last is minus 28. Combine like terms, and there's my function, x squared plus 3x minus 28. Ooh, my box making skills on this tablet is not great. Okay, well, why don't you pause and try this one on your own? Okay, so the end result would be x is equal to 5 or x is equal to negative 5. Okay? So let's get it as our factors. X minus 5 equals 0, x plus 5 equals 0. So that means we have x minus 5 here, x plus 5 here, and now we FOIL these together. First, x times x, outer, 5x, inner, negative 5x, last, minus 25. So this is a difference of squares. Those cancel. X squared minus 25 is equal to 0. So my function is x squared minus 25. Those are the function. That's the function that makes those zeros. All right, I hope we're having a good day, and I'll hopefully see you soon. So long, folks.